Hi, I'm Jenny Hill, and I'll be going over elk management in Montana, specifically creating a spatial database to help establish a prioritized monitoring system. So just what I'll be going over today, I'll introduce the topic of elk management in Montana and why I picked this topic. Also identify elk management units, the plan that was established by Montana Fish, Wildlife, and Parks, the goal, the ear diagram, domain, as well as subtypes, topology, Montana elk habitat, identify issues that occurred in future work, as well as my references. So just an introduction. In 2003, Montana Department of Fish, Wildlife, and Parks produced a Montana statewide elk management plan. This plan was developed because of the issues and problems elk population has faced in Montana. In this plan, I outline just the history of elk in Montana since they were widely dispersed throughout the exploration of Lewis and Clark in the early 1800s, and they were documented in Lewis and Clark's diaries and journals during their exploration. These elk populations were then nearly eliminated, and in the early 1900s there was an estimated that fewer than 50,000 elk population existed throughout all of North America. Elk herds were then planted during the 1940s to help increase the population recover, and in Montana, elk populations have increased from an estimated 8,000 in the early 1920s to about 160,000 today. Also, this plan outlined management practices, which specifically outlined these monitoring management units. There's 55 of them statewide, and they cover 147,200 square miles. So here's just where they all are, and in addition to the most recent elk population distribution data that is out there from 2008. So you can see there's 55 different elk management units, and they cover all of Montana, each identified with a specific name. These names also correlate to the county for most of them, except for a couple that are larger than the actual county because elk populations don't really go there. That's not their specific habitat. It's important to note that Indian reservations such as Flathead Indian Reservation is located in the northwest corner, doesn't have any information, as well as the other Indian reservations, because they fall under different regulations. So there's no elk population data for these areas. So the elk populations wouldn't be where they are today without the establishment of management areas and regulations. And this plan helps establish and develop these practices even more to a sustainable manner that helps keep animal populations at a number that doesn't adversely affect Montana land, since many residents in Montana rely on the land for farming and agriculture and to make a living. So we want to help balance the interaction between humans and the wildlife. And most importantly, elk is a huge game animal, and a lot of hunting goes into them, which helps fund Montana Fish, Wildlife, and Parks and U.S. Fish and Wildlife Services to help them implement these plans. So there needs to be a good balance. You can't completely restrict all hunting, because then that kind of cuts off the funding source, which in today's economic situation, these budgets are more limited, so monitoring and management needs to be performed with as much precision and reliability as possible. And one of the ways we could assess this would be to use like a spatial analysis to assess the various land uses, hunting areas, habitats, as well as predator distribution in relation to elk, and assess these elk management practices and areas, However, in order to do that, we would need reliable data and to have it all in one location, which there isn't a database that contains all of this information and essentially located and integrates all the information to perform such spatial analysis. So my goal is to establish a spatial database to organize and help put all this data in one location to help determine which elk management units have the greatest habitat disturbance, whether it's natural caused by forest fires and predators or by human caused such as urbanization, and then establish a priority to monitoring and spend our money wisely. So for the spatial database, I kind of use Esri's integrated ArcGIS data model concept to use as a template, and then further develop specifically for elk population and management in Montana. This database will be used to help analyze elk populations in relation to their habitat and other entities such as more in-depth biodiversity units including flora and fauna, since elk rely heavily on the habitat to have good canopy cover, adequate water supply, and less predator stress from wolves and mountain lions and bears. All of these factors need to be kind of included, such as like the elk distribution, the occurrence, populations of both current and historic, since we want to compare the population trend, as well as the observer. You want reliable data, so we need to factor that in as well. Each one of these also has the relation linked up to it, so for every observer he could have multiple observations which identify multiple species. However, that observer has a different quality, whether he's accurate or he's not, as well as area and elk management units. For this, I've established domains, as mentioned, the observer, and broken into the observations and the observer quality, biodiversity unit, which can further then be broken down into different flora and fauna, and area, which is directly linked to elk population units. And these domains are used to create a simple features, including the predicted potential historical and known distribution, since we want to compare these management practices and determine the successfulness of them. From there, I used several subtypes. Area, limited to 2, nature-based and administrative. That way we could determine, is this an area that we are doing something to help protect elk populations, or are we not? Is it in its natural state with little human interaction? Biodiversity type, we want to focus on stuff that directly impacts elk populations. So that's the elk themselves, predators such as bears, mountain lions, wolves, and certain fauna and flora that kind of relate. We don't want the observer inputting data on specific bird species that may not directly affect the elk population themselves. And also classify the area, kind of limit the specificity. That way we're just focusing on urban and agriculture, water specific, kind of broader categories. That way we're not going into so much detail into like whether it's a coniferous forest or deciduous, just a forest canopy cover. That's how it will directly impact elk populations. Also, to help maintain data integrity, we put a couple rules and restrictions. So for every observation, the point must be properly inside a polygon, and that polygon must be covered by the elk management unit. So directly relate those two. And elk management units can share boundary. We don't want gaps where an observation might fall into an area that hasn't been identified by a boundary, and then so that elk management unit then is also covered by the Montana state boundary, since we want to focus on the state. And also landscape habitat, we don't want it to have any gaps, and also have it covered by Montana boundary. So for example, this is just an illustration what I meant by the habitat having no gaps. This map is filled and also using those specific domains and subtypes for the habitat, including urban, agriculture, rangeland, forest, water, and other. So you can see the map is full and also has the delineation for the elk management units. So some issues that occurred while I was establishing the spatial database is that there isn't any reliable up-to-date data. The most recent is 2008, and that being the elk population, and also not all of the data sets contain the information where I could directly link them or were organized. So I wasn't able to really populate the spatial database more beyond just the elk habitat map that I just shown. So future work would be to find more relevant data, which then I could populate the spatial database with and assess the populations in relation to habitat disturbance and potentially perform a spatial analysis. So here are my references. I'd be happy to answer any questions if you have any. Thanks.